Alright, so we're ready for the second page of 10.6 notes. On this page, we're going to solve what are called literal equations that involve radicals. Literal equations, again, are equations with multiple variables where you're solving for one of the variables in that equation. So, as an example, we'll just jump into number 7 here. We want to solve for L in this equation. So you might think, well, what am I going to do to both sides of this equation? And hopefully your gut tells you maybe we should square both sides to get rid of that square root. So let's do that. We're going to square both sides. If we square both sides, we have z squared, and the square undoes the square root, right? So we get z squared equals L over c. Now we're asked to solve for L, so to move the c to the other side, since L is divided by c, we're going to multiply both sides by c. And then the c's cancel out, and so I'm going to write this with our L first. So L is equal to c times z squared. So c z squared. Simple enough, right? Let's look at the next one. We're asked to solve for c. Now this can be a little more tricky when the variable you're solving for is in the denominator, but we can fix that pretty quickly. Let's move everything we can to the left before we actually start trying to square both sides or anything like that. So this 2 pi we can move to the left. Since we have 1 divided by all of this, we could multiply both sides by 2 pi. So that's what I'll do. I'll multiply both sides by 2 pi. We do that on the right, the 2 pi's cancel, right? So that's a good first step. So on the left, then we have 2 pi f. On the right, we have 1 over the square root of LC. Now, just like before, if we want to remove the radical, we can square both sides. Okay, so maybe we'll do that. Let's square both sides, why not? And we have a 1 squared, which is just 1, so it doesn't change the numerator on the right. So on the left, we just have, I'm going to just leave this in parentheses, 2 pi f quantity squared. On the right, 1 squared is 1, and the square root of LC squared, well, the square root and square cancel each other out, we just get LC. So that's a good step forward. We don't have any radicals. Now, so what else do we need to do? We want to solve for c, so we need to try to get rid of this L on this side. So maybe I'll multiply both sides by L. Okay, so the L's cancel over here. So what do we have so far? So we have L times 2 pi f quantity squared equals 1 over c. So we're almost there. We just have our c in the denominator instead of the numerator, right? Well, we can fix that. There are a couple ways we could do that. But if you want to take a variable that's in a denominator and move it to a numerator, you could multiply both sides by that variable. So let's do that. Let's multiply both sides by c. Here the c's cancel. On the left, then we have CL times the quantity 2 pi f squared equals 1. But we want to solve for c. So guess what? We can move all this stuff to the right by simply dividing everything by all that stuff. L times 2 pi f quantity squared divided by L times 2 pi f quantity squared. And so all that cancels over here, and then we have our c equals 1 over L times 2 pi f quantity squared. Easy enough, right? That's not terrible. Let's look at the next one. We're asked to solve for r. In this one, again, we have an r. It's in a denominator, makes it a little harder, and we have a radical involved. Let's move everything that's not under the radical to the left and get it away from r. Okay. So we're really dividing by 2 pi. We have 1 divided by 2 pi. So let's multiply both sides by 2 pi here. So multiply by 2 pi on both sides. 2 pi's will cancel here, right? And on the left, let's see, we have 2 pi n. On the right now, we have 1 times the square root of a over r, which is just the square root of a over r. Okay, and now we have the radical by itself, just like we did when we had the equations with the numbers and things. Once we have the radical by itself, we can square both sides. So let's square both sides. So now on the left, we have the quantity 2 pi n squared. And on the right, we just have a over r. Square root and the square cancel each other out. Okay, now again, if we want to solve for r is in the denominator, let's move it to the numerator by multiplying both sides by r. R's cancel on the right, and then we end up with r times 2 pi n quantity squared equals a. Now if we want to get r by itself, since it's held together by multiplication, we do the opposite operation. We divide both sides by all this stuff next to the r. So we divide both sides by 2 pi n quantity squared. And so that goes away. Now we have r completely solved for. We got r by itself. So r is equal to all that stuff, a over the quantity 2 pi n squared. And we're done. Not terrible. Some people get a little nervous when it's all variables, but the operations we do to both sides are no different than if we had numbers. Alright, so that's it for 10.6. We'll start in chapter 11 on the next video.